live from Earth. It's Space Radio. This is Paul Sutter, and we're coming into... it's been too long. Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about life on Venus, and of course, taking listener questions about all things in this universe, because that's what this show is about. We record every Thursday at 8 p.m. Eastern, and you can follow along online or leave a voicemail at spaceradioshow.com. And in today's Blue Shift, I'll be talking about on self-propelled solar sails. But first, the news. Hello, Space Cadets. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your Agent to the Stars got an amazing show for you today where we talk about all the amazing things in the universe. This show lives on listener questions. We record every Thursday at 8 p.m. Eastern here at Spaceman Studios in New York City. So leave a voicemail at spaceradioshow.com to get your question on the air live. You can also follow along with our Space Cadets joining on our live streams on YouTube and Twitch. Go to spaceradioshow.com for those links. We'll answer questions that you send there too. Seriously, folks, I've prepped basically no material, so get those questions in. Space Cadets, it is so good to see you. I'm a little rusty, aren't I? I'm a little rusty. Wow. If I feel rusty, but I'm feeling good. I want you to know I feel good. It's been a while. Guys, I had some nasty. I had some dental oral surgery going on a couple weeks ago. It's taken me some time to recover. The inside of my mouth just looked like raw hamburger. That's all I'm going to say. And it took a while to not look like raw hamburger. I'm still healing, but I'm feeling good enough to do the show. But understandably, I had to pause a lot of my recordings and broadcasts and everything in order to do this show. But it is good to be back. And hello, everyone tuning in from around the world, including but not limited to Ottawa, Canada, Halifax, England, Portsmouth, UK, Vilnius, Lithuania, Darmstadt, Germany, Howell, New Jersey, and Pell City, Alabama. It's a competition today for the most exotic city. Tuning in live. Guys, you know I got to talk about this whole Venus thing, right? You know that's what's coming. You knew that was going to be. And Nova Scotia, how's it going? And Washington, D.C. I need to keep this lubricated, folks. It now looks like cooked hamburger inside my mouth. We're not gonna look too deeply right here. It looks more like cooked hamburger than raw hamburger. Whew. Hopefully it's the last one. Hopefully. Okay, let's just talk about Venus. I got to. Before I start taking questions, I wanted to share some interesting bits of news I caught recently. And this week, the astronomical world blew up about Venus of all places. Wow, like who cares about Venus? Apparently, some astronomers I'll give you the breakdown and then my take on it. So astronomers were like, hey, we're looking for signs of life. If we can identify certain elements in a planetary atmosphere, it might be evidence for life. Like, say, oxygen. Oxygen on the Earth in our atmosphere comes from photosynthesis. It comes from life. So if you see a lot of oxygen, there's a good chance it comes from life. One group of researchers has honed in over the past few years on phosphine. Phosphine is a molecule made of phosphorus and then 3 atoms of hydrogen. It's very stinky. It's relatively rare on the Earth. The only places it comes from on the Earth is from anaerobic bacteria, like little critters like pooping and farting out phosphine, and it's fine. But these researchers said, hey, if you look at a rocky world and you see a lot of phosphine, there's hints that that could be a sign of life. Now, we see phosphine, a lot of it, in the atmospheres of Jupiter and Saturn, and we don't think that has anything to do with life because the interiors of those planets are super hot and super dense. You can get really weird chemical reactions that can then float up to the top where we can see it. So just the presence of phosphine itself isn't an indicator for life, but the researchers have been arguing for a few years that if you were to find this around a rocky planet where there aren't those kinds of high temperature, high density reactions going on, if you see a lot of phosphine, then that's evidence for a lot of anaerobic bacterial action going on. Another group of researchers was studying the planet Venus because somebody does, and they knew the people that were working on this whole phosphine angle, and then they went across the hall and said, look, we found a bunch of phosphine in Venus's atmosphere. So they released a paper, they released a joint paper this week and did a whole big press conference as a big to-do about phosphine in Venus's atmosphere. And the bulk of the paper is going through all the scenarios where the researchers think that chemical reactions could lead to phosphine in Venus's atmosphere, and then saying how they're not plausible or they don't work out. Like, oh yeah, you can get phosphine in, say, volcanoes, but in order to get this much phosphine in Venus's atmosphere, you need like a bajillion volcanoes, or maybe there could be like cosmic rays, but we need like 11 billion times more cosmic rays than we actually see. Basically, trying to be as creative as possible, come up with as many chemical pathways to get that much phosphine in Venus's atmosphere and crossing them off the list and then saying, hey, we can't get phosphine chemically in Venus, so maybe there's a bunch of critters running around. Now, I'm almost out of time on my little news segment, but I'm just going to go ahead and bowl right on over into the question segment. Normally, this is where I'd stop, but this is such a big topic, and I want you to understand my take on it, which is not going to be very, very excited about it. Now, here's the thing. This is, I don't want to say it's a nuanced position because that makes me sound like pretty hoity-toity. I think the researchers, I'm not going to blame any astronomer for wanting to be the first one to identify life outside the Earth, because whoever does that is like going down in the history books. We're talking Nobel Prizes, we're talking breakthrough prizes, we're talking like buildings named after them. Like the discoverer of life outside the Earth is a huge prize. Okay, so I don't blame any astronomer for jumping to that of saying, look, we think we may have found life. Because if you're wrong, it doesn't cost you much, just a little bit off your reputation. But if you're right, man, it is just going to blow up for you. You're set scientifically. So this is not the first time astronomers have claimed the existence of life outside the Earth. There have been stories about life on Mars, evidence for life on Mars going back decades. So to turn our attention to Venus, which one of the things I want to point out is we know very, very little about Venus. We have studied Venus way less than we have studied Mars. And think of all the ups and downs in our journey with Mars, like life, not life, maybe life, not life, ancient life, not sure. Okay, oh, water on Mars. It's wet. No, sometimes, maybe, no, actually it's not. Like, maybe it is. Like, and that's with us studying it so much. Now, Venus, we've barely studied compared to Mars. Venus is just like, okay, Venus sucks as a planet in general. Let me get that out. It is temperatures over 800 degrees Fahrenheit. It's hot enough to melt lead on the surface. Air pressure is like 100 times that of the Earth's, or 90 times that of sea level on the Earth. The atmosphere is carbon dioxide. It is sulfuric acid. It is nasty, 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 nasty. Nobody wants to go to Venus. What the researchers are claiming is that because they can't think of any chemical reason to generate that much phosphine, that maybe there is life on Venus. Now, in that kind of hellhole where you find life, there is a band in the upper atmosphere. It's a few like 20 or 30 miles up in the atmosphere. The air pressure is relatively like the Earth. The temperature is relatively like the Earth. And so if you're looking for like habitable places, that would be it, tens of miles up in the atmosphere. Of course, the atmosphere is still pure carbon dioxide and sulfuric acid, and it's horrible. But hey, life has thrived on Earth in worse conditions, so it's not completely out of the question. But here's the mistake that I think the researchers are making. They did a very thorough job of trying to come up with a chemical reason to generate that much phosphine in the Venusian atmosphere, and they couldn't think of anything. And so the last thing on their list, as improbable as it is potential life. Okay. And of course, the paper and the abstract are written very carefully, like, either there's a complex process happening on Venus to generate phosphine that we previously didn't understand, or there's life. Fair. You can also define life as a very complex chemical process that we don't understand, in which case it's all just chemistry, but I'll leave that. That's not my field. I'll leave that to someone else. So let's take it at face value. Either there's a chemical process that we don't understand, or there's life. Really, that's where the paper should end. Really, the paper should have ended with, we don't understand where the phosphine is coming from. Like an actual observational paper, like, hey, we detected a bunch of phosphine. We don't know where this phosphine is coming from. Let's have at it, boys. But like, you don't win Nobel Prizes for saying that. You win Nobel Prizes for saying maybe there's life and developing a research program along those lines. The issue I have, of course, is the way the media spins this. And then all the astronomers involved in this study just feed it by giving it quotes and quotes and quotes, by saying, maybe there's life, maybe there's life, maybe there's life. We have to look at the evidence. The evidence is there's a bunch of phosphine, a random element that prior to this week, nobody cared about, but now everyone knows how to spell it. There's this random element on Venus. What is causing this random amount of a high amount of phosphine on Venus? We don't know. Period. We don't know. Period. That is it. We don't know what is causing the excess amount of phosphine in Venus. We simply don't know. We do not have any evidence whatsoever for any pathway leading to phosphine on Venus. We simply don't know. So you can enter some hypotheses. Hypothesis A, it is some chemical process or geological process that we haven't thought of yet. Or hypothesis B, it's life. Now, when you have two hypotheses that are equally supported by the evidence, you do have tools available to choose between them. This hypothesis A, where yes, there's just some chemical process or geological process we haven't figured out, and hypothesis B, yeah, there's life. They have equally supported by the evidence so far, which is a lot of phosphine. I do have to take a break. Listen, I'm Paul Sutter. This is Space Radio. This show is brought to you by you. Please go to patreon.com/PMSutter to learn how you can keep my rants going. And we'll do this. We'll do this more after the break. Yep, that's it. Gotta take a break. We're good. We're good. That's not water. A lot of exhales in this rant. Are you guys along for this ride? Do you see where I'm going with this? I hope you do. I hope I've set it up. Let's do it. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more questions. Actually, no one's answered a question. Actually, lots of people have, but I haven't gotten to it because I'm in the middle of a rant. But you can join the conversation when I let you, or by leaving an online voicemail, or by following the live streams. Check out spaceradioshow.com for the links. We're talking about Venus. We see a lot of phosphine. Hypothesis A, unknown geological process. Hypothesis B, life. Which of these is more complicated? Which of these is harder? Which of these involves more entities? Which of these involves more stuff? Like, wow, I can't imagine some geological process and chemical process that could lead to this much phosphine. Okay. I also can't imagine how life could thrive to the levels necessary to generate this much phosphine on Venus. Everything that the researchers say about how bewildering the chemical processes could be to generate this much phosphine on Venus can be directly copied and pasted to a discussion of life on Venus, plus some more steps. Folks, life is hard. If life were easy, it would be everywhere. But we don't have any solid evidence of life anywhere, and we've looked even under the couch cushions. Phosphine itself is not enough to claim even the potential of life, because the life hypothesis is more complicated, involves more steps, involves more entities than the chemical process, the unknown chemical process. Yes, we don't know chemically how phosphine could arise on Venus. We also don't know how life could arise and sustain itself and thrive and generate so much phosphine on Venus. We also don't know that. So you can't. I believe this is just one of my core philosophies of science, that you can't make this jump. You can't say, I don't know, or I can't think of a way to get this much phosphine, therefore life. That's not a jump you're allowed to make. If you don't know how that phosphine got there, you don't know how the phosphine got there. And thank you, Shay, for the $5 to continue this rant. Guys, what I'm describing is Occam's razor. Occam's razor is simple. Entities should not be multiplied beyond necessity. We have two choices: an unknown chemical or geological process to lead to a bunch of phosphine on Venus, or life to generate phosphine on Venus. And without further evidence, we must choose the simpler hypothesis. And the simpler hypothesis does not involve life, because life is complex. It's about as complex as you can possibly get in this universe. There could be life on Venus, of course. I'm willing to say that there could be life on Venus. Excess phosphine in the atmosphere is not going to be the clincher. Having a lack of imagination and not knowing what kind of crazy geology and chemistry that could take place on Venus to generate that much phosphine is not enough to do it either. There could be life on Venus. There could be life on Mars. There could be life on Mercury. There could be life inside Jupiter making all that phosphine. There could be life on Saturn. There could be life on Europa. Yes, there could be life on Venus, but that isn't necessarily bolstered by the presence of phosphine. This research is less than a week old. Given a month, we're going to have a dozen different competing hypotheses about how to generate that much phosphine on Venus. Or, in addition to, further observations might reduce or refine the strength of the signal. Maybe they're overestimating the amount of phosphine in Venus's atmosphere. The researchers themselves say, we're confident in our observations, but it is not confirmed yet. So things could change in the next few months. Whoops, okay, we overestimate the amount of phosphine by a factor of 10, so we got to drop it down. And then, Venus went through a global resurfacing event 500 million years ago and totally turned itself inside out. And when you put these together, phosphine is just present as part of the Venus's atmosphere. It's also possible that we'll never have a satisfactory explanation for the presence of phosphine. It's also possible that we will send probes into the Venus atmosphere and we will not see any life at all, and we'll still don't know why the phosphine got there. It's also possible that we'll drop probes into Venus and find life and find out it has nothing to do with the phosphine. It's also possible that we'll drop probes into Venus and we'll find life and it is responsible for the phosphine. All of these options are possible until we have more evidence. Until we have more evidence, then we have to lean towards the simpler explanation. The simpler explanation is less sexy. The simpler explanation is less interesting than the vast majority of the human race. The simpler explanation is likely to be correct through Occam's razor as a guide. Guys, you know my mantra, one of my mantras is if it's interesting, it's probably wrong. I am applying that to this. Life on Venus, the result of life on Venus is interesting. It is probably wrong because interesting things are really, really hard to come by in this universe. I'm sorry, it's just the way it is. I am willing to be corrected. I am willing to be wrong. I am willing, and I would love for there to be life on Venus. Do I, right now, in this moment, on September 17th, 2020, believe that there is life on Venus based on the evidence at hand? No. Do we have a mystery afoot as to the presence of all this phosphine on Venus? Heck yeah. I don't know how it got there. I don't have a good hypothesis for it, but I'm going to lean towards the simpler hypothesis with the fewer entities, with the least amount of complexity that explains the available evidence. And that is going to be a chemical or geological process that we haven't thought of yet. Is that enough? Is that enough rant about Venus? It's more about the presentation of the idea than the idea itself. Yes, phosphine is a mystery. No, we don't understand where it's come from. Yeah, it's really interesting. We don't know. Why are we jumping to life? I mean, yes, these researchers worked really hard in years past to say, like, if we find phosphine, it's a signature of life, but they haven't ruled out It's not just a matter of ruling out the alternatives. You need positive evidence for life. It's just phosphine by itself isn't enough. Phosphine by itself isn't enough. Just having a lack of imagination or creativity isn't enough to claim the detection of life or the possibility of life. That's where I am right now. That's where I am right now. We'll see. I am betting. I'm willing to bet like $20. Anyone want to take me up? But just one of you can take me up on this. That when we revisit this story a year from now, 2 years from now, it's not going to go really anywhere. Because if it's interesting, it's probably wrong. I need to calm down. It's time for the blue shift. Wow. Yeah, that's where I sit. Like, life is complicated. Yes, life can possibly create phosphine. Life can also make like 1,000 other things in excess. No, we haven't thought of a chemical process. But the non-life explanation is going to be simpler than the life explanation at the end of the day. Make it 40. Gordon Dewis, you and me. You were the first one. You and me. It's on $20. $20. That's a real 20. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. I'm wrong all the time. I say wrong things. I say incorrect things. Sometimes, because this is a live show, like people ask me questions and I give you answers off the top of my head. Sometimes I rant. At the end of every show, I eat cheese. For you, those of you listening on the radio or podcast, you missed that part. And sorry, for your luck. One time, a few weeks ago, someone asked me about self-propelled solar sails, where if you attach a solar sail to, say, the front of a spacecraft and then shoot a laser at it and bounce the laser off the solar sail, would you go anywhere? And I talked about conservation of momentum and how you'd be stuck. I was wrong. In my haste to answer the question, I forgot some subtle aspects of reflecting lasers. You will propel yourself if you have like a big reflective thing in front of your spacecraft and you shoot lasers forward and it bounces off the thing and then aims backwards. That will move you forward. It's the exact same thing as if you were to just shoot the lasers out from the back end and skip the whole solar sail. This is not going to be very effective at all because light has no mass. It has a tiny bit of momentum. You could just shoot a giant laser out your rear end for years on end, and it will not move anything appreciably large, like a rock. It will take like 10 years to accelerate the rock to like 100 miles an hour. I'm making up numbers now just to make my point. Yes, you can have a self-propelled solar sail. It's the exact same thing as shooting lasers out your back end. Shooting lasers out your back end is not the most efficient way to drive a spacecraft. Maybe I'm wrong about life on Venus too. Who the heck knows? The evidence will decide. The evidence is the ultimate arbiter of all of our knowledge. That's all it takes is more evidence. We'll keep studying Venus. Either we'll find life or we won't. Right now I'm leaning towards won't because that's the simpler explanation, and simpler explanations are an efficient way to navigate multiple competing hypotheses until the evidence convinces me otherwise. If the evidence demands a more complex hypothesis like life, then boom, you lean towards life. But only once the evidence demands it, and the evidence does not yet demand it. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Please visit patreon.com/pmsutter to learn how you can keep this show going. Thanks to Greg Mobius for producing, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio 90.5 FM for making this show possible. Catch the live stream every Thursday at 8 p.m. Eastern. Visit spaceradioshow.com for all those links. You can follow me on social media at Paul Matt Sutter. You can tell me how wrong I am. And of course, thanks again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission. Yeah, Alien of Soul 3, extraordinary claims require extraordinary evidence. That's just Bayesian reasoning. It's another way of like this Occam's razor. Like if you want to claim life, you need a lot of evidence to support that. And just like not being able to come up with some chemical reasons to generate phosphine isn't enough. You have to weigh, you have to fold in your prior knowledge into your hypotheses. Now I've got cheese, folks. I've got cheese, which is good because coming off a big rant like that, I could use some good cheese. I've got some raclette. I got it prepackaged and pre-cubed up. I know like cheese purists are cringing right now, but just roll with me here. It's all I got. It's a raclette du Haut Livradois from Fournois, France. Société Fromagère du Livradois, Ververnas, aged over 60 days. This is a semi-soft cheese. Now, raclette is actually like, I think it originated in Switzerland, but it's very popular in France. And now what you do with, I'm eating raclette the wrong way. The best way to serve raclette, and this was one of my favorite things to do when I lived in France, was you buy a block of raclette. And then they're big, it's, like fondue pots, but it's like skillets, like little mini skillets, and you melt the raclette, and then you pour it over bread or potatoes or like right into your mouth, and you get that gooey creaminess. It comes from a lovely Swiss tradition of bringing like a big wheel with you when you're like hurting the flocks or whatever, and then you let the fire melt the cheese and you scrape it off onto your bread. And so yeah, raclette is meant to be eaten melted, but I'm still gonna enjoy it. And this is a French brand, Raclette du Haut Livaudan. Raclette is really fun. It's like a mix of Swiss with like the nuttiness and intensity of Parmesan. There's a deep woodsy note that I absolutely love. Some sausage with that would be fantastic. I agree. This is a good cheese. If you can get yourself some raclette, I would recommend it. Because that's a good cheese. And now I don't feel the need to like want to rant anymore. See, cheese just calms me down. Cheese is my therapy, and I'll